In this video, I will show you how to solve a system of equations using matrices. And the method I'm going to use will allow us to also determine if the system has no solutions, exactly one solution, or an infinite number of solutions. Those are the only options. There's no way for it to have exactly 3 solutions or anything like that. Okay, so my method involves making a matrix called an augmented matrix. We're going to use all of the coefficients, including the numbers to the right of the equal signs. Don't forget that if there's no number visible, it's a 1. So, for example, this would be a -1, and this is a -1, this is a -1, this is a +1. So let's type this matrix in. Notice this has 3 rows and 4 columns, including the solutions at the end. So this is a 3 by 4 matrix. So let's go to the matrix area by hitting second matrix. We need to go to the edit menu, and I'm just going to use matrix A. So like I said, this is a 3 by 4 matrix, so I have to change the dimensions. And now we'll start typing. So we have 4, -1, 2, -1. And then we have -1, 2, 5, 2. And the final row is -1, 1, -3, 1. Alright, so that's matrix A. So let's quit our way out of here. So we want something called reduced row echelon form. So let's hit second matrix and go to the math menu, and we're looking for something called reduce row echelon form. So let's scroll down until we find it. Okay, so see this RREF? That's reduced row echelon form. So I'm just going to go ahead and hit enter. Now we want the reduced row echelon form of matrix A. So let's go back to the matrix area and choose matrix A. Okay, and then just hit enter. So this is the reduced row echelon form. Now this gives us the solution, and here's how. Okay, remember how this last column represented the numbers to the right of the equal sign? Well, guess what? They still do. Now, in the first column, we had the variable x. Okay, these zeros mean there are no y's and there are no z's. In the second row, we have a 1 for z. For y. So this is 1y. And this 1 represents z. Okay, basically ignore all the zeros, just look at the 1s. So this tells us, the first row tells us that x equals 0. And the second row tells us that y equals 1. And the third row tells us that z equals 0. So this is a solution, which means it is the only solution. So for this particular problem, whoops, clicking on the wrong thing. For this particular problem, the answer is the solution, the system has exactly one solution. So let's take a look at that. Okay, and the solution is what we just found, 0, 1, 0. So not only did we find that it has one solution, but we found what that solution is. Now, quickly, let me show you what it would look like if there were no solution. Okay, maybe I'll just draw this over here. Imagine a matrix like this. Okay, so we have 1, 0, 0, 0, 1, 0. And over here, it doesn't matter what these numbers are. Let's say it's 2, 3, and 4. Okay? Now, if there's going to be one solution, then I would have 0, 0, 1. And this would tell me x equals 2, x equals 2, y equals 3, and z equals 4. That's what this would mean. But imagine that instead of a 1, right here we had a 0. Okay? That's when you have no solution. Because right here, this is saying that 0 equals 4. Okay? Because it's saying, this would mean 0, z, for example, is equal to 4. But, well, 0z is just 0. And we know that 0 does not equal 4. This is a false statement. So this is what it would look like if there was no solution. You'd have a 0, and it would be a false statement. Now, what would it look like if it had infinitely many solutions? Okay, well, it would be very similar. We still have a 0 right here, but instead of a 4, we'd have another 0 over there. Okay, this is what it would look like if it was going to be infinitely many solutions. Because this means 0 equals 0, well, that's always true. So that creates infinitely many solutions.